The following video will cover the one-way analysis of variance, or ANOVA, example that's given in Chapter 6 notes about bone strength that were taken from a sample of femurs from cadavers of 3 different age groups. So you'll notice in the notes that we were going to compare the mean bone strength from these 3 age groups. We had young individuals, we had middle-aged individuals, and then we also had elderly individuals. Now, the data that was given in the notes looks slightly different than the data that was given, or that is shown in the StatCrunch dataset. You'll see in the StatCrunch dataset, we actually just have 2 columns of data. The first was the force that was required to fracture the femur, and the second column was the age group that that femur belonged to. Now, what we've done in this case is we'd like to test the null hypothesis that there's no difference in the mean bone strength for the 3 age groups versus an alternative that there is some difference between these 3 age groups. Now, the test that we're going to use in this case is not a t-test anymore, because a t-test only allows for the comparison of 2 independent groups, and in our case we have 3, because we have the young, middle-aged, and elderly femurs that were sampled. So what we've got to consider is the new technique that's discussed in these notes, that's analysis of variance. Like the t-test, analysis of variance had many of the same assumptions, one of which was that we needed our data to be normally distributed. Now, to create histograms of this force variable, we're going to have to take a slightly different approach than we've done before. In all of our previous data, we had individual columns. So instead of having one column that just contained our force, we would have had one column for young, another column for middle-aged, and another column for elderly. StatCrunch can still handle individual graphics for one column of data, and to do that we'll go through the following procedure. So if we pull up our histogram dialog box, you'll notice now that there's only one column that you're able to select. So we want to make a histogram of the force, but I don't want all of the measurements grouped together. Instead, I'd like to group those measurements by the age group which they're associated with. And then I'm also going to check that I would like a separate graph for each group. And you'll notice in the notes that mine are all side by side, and you can actually do this as well. So if we click Next and go through until the very last slide, you have a graph layout option. So I would like my graphs to appear in one row, but in 3 different columns. And what that will give you is 3 side by side histograms. Now, you'll notice in both these cases, none of the distributions of bone strength appears to be incredibly normal. Now, technically, for an ANOVA assumption to be met, we would need all 3 of these histograms to appear normally distributed. So at that point, you'll notice that I'll say we're going to proceed with caution because we do have some problems with our normality assumption. Also, like the t-test, we have to assume that our variability is equal across the samples. And the way that we assess that will remain the same as it was with the t-test. So again, what I'd like to do is I would like to pull up summary statistics. So if we go to the summary stat menu, you'll notice again that force is the only column that you can select. And if you select this and hit calculate, you're going to get incorrect output, because you'll notice in this output that these are the summary statistics for the combined 29 measurements. I need summary statistics for each individual age group. So if we go back and edit that previous dialog, again I want to select that we're going to group by age group. And if we hit calculate there, then here's the familiar output that you're used to. Now, if we look at our standard deviations, we see that twice the smallest standard deviation, so that standard deviation associated with the elderly group, is barely greater than our largest standard deviation of 32 that was associated with the young group. So we have met the assumption of equal variance, although by a minuscule amount. So again, you'll notice in the notes that I have also pointed that out. Now, With just the summary statistics, it looks like the elderly have the weakest bone strength, middle-aged falls in the middle, and the young is the largest. But I ranked those values just by looking at my 3 sample means. That's not a statistical inference because I'd like to compare the mean bone strength for all femurs in these age groups. So in order to do that, I have to do some type of an inference, and that's where ANOVA, analysis of variance, comes into play. So your ANOVA menu is under the stat box, and you'll come down to ANOVA, and in our case we are doing a one-way ANOVA because we have one factor that we're interested in, the age group. In the one-way ANOVA you have 2 different options. You can either compare columns or you can compare values in a single column. In our case, we actually just have a single column. The response that we'd like to compare is our force, and the factor we want to compare that force across is the age group. Now, it's important in this case that we check the Tukey HSD. Now, it sounds funny and we didn't talk about specifics, but that checkbox is going to allow the multiple comparison output to also be printed. And since we wanted to conduct this test at the 0.05 level, a confidence level of 0.95 is the correct choice. So you'll notice that we have a repeat at the top of some of our summary statistics. So for each age group we have our sample size and our sample mean. And then what's important for us right now is this ANOVA table. Now, the calculations involved in an ANOVA are quite time intensive. So all that we're actually interested in are these last 2 columns. The F stat, that is our new test statistic, so we're using an F statistic. And then the last column of the table gives you your p-value, which will allow you to make a decision. Now, in our case, the p-value is less than 0.05, so with that in mind, we'll reject the null hypothesis, and the conclusion that we can draw is there's evidence of at least one difference in the mean bone strength across the 3 different age groups. Now, here's the problem. Saying that there's at least one difference does not tell you where that difference falls. So that's where the confidence intervals given at the bottom, the multiple comparisons, come into play. And you'll see what's calculated is various confidence intervals for each pair of means. So the first row of our table, where we have middle-aged, compares middle-aged to elderly adults. The second row compares young adults to elderly adults. And the last portion of our table compares young adults to middle-aged adults. Now, essentially what's happened is you've calculated a confidence interval for the difference in those population means. So when we compared middle-aged to elderly, we see that we had both a lower and upper limit that's positive. So we can conclude that the mean bone strength for middle-aged adults is between 2.577 and 57.372 newtons larger than the mean for elderly adults. Similarly, if we compare young adults to elderly adults, we see 2 positive limits. So again, we're able to conclude that young adults have a greater mean bone strength than elderly adults. But if you look at the very last confidence interval given, the young adult lower limit is negative when compared to middle-aged adults, and its upper limit is positive. Since this confidence interval goes from a negative lower limit to an upper or a positive upper limit, we're unable to say that those 2 means are statistically significantly different. So in these comparisons, we were able to pick out some differences. So the elderly mean bone strength is the smallest, but there was no difference between middle-aged and young's mean bone strength. In the notes, there's a second example that deals with an analysis of variance. For that example, our data is structured slightly different, so we'll pick up with that example on a second video.